Hi, I'm John, and I'd like to welcome you on a short demo of CloverETL Server clustering. I'd like to begin with an overview of this presentation. I'll start by explaining why clustering, and how the CloverETL Server approaches it. In the second part, I'll give you a live example of the CloverETL Server cluster scalability and failover capabilities. CloverETL Server is our server class ETL tool used for data transformations, data integration projects, data warehousing, data quality, and so on. It's built upon the CloverETL engine, and it adds advanced features such as user management, system administration, scheduling, and much more. The CloverETL server cluster achieves first-class availability of service and performance scalability by allowing you to use multiple server instances. Multiple servers provide you with increased performance using automatic transformation load balancing. Additionally, multiple servers give you the redundancy needed for failover capability, bringing you top availability of service. The approach chosen is a cluster of CloverETL server work nodes. All of these nodes can execute the same transformations on the same data, so they act as interchangeable black boxes, producing the same results. That means that the nodes share the same configuration, such as user accounts, and the same data on all shared file systems. Clients call the CloverETL server functionality via its HTTP APIs. All of the cluster nodes can delegate an incoming client's request to another node, so together they cooperate in load balancing the whole cluster. As an example, a cluster node can delegate a request to run a transformation onto another node. The load balancing uses an automatic algorithm, which is configurable by the cluster administrator. All of the cluster nodes are hidden behind an HTTP load balancer, which acts as a single point of entry for the clients. This ensures that the clients are not connected to any one of the cluster nodes directly, and the HTTP load balancer forwards their requests only to the living nodes. This way, a node failure is invisible to the client. Here you can see an overview of a sample CloverETL cluster setup, and I'll be demonstrating it live in a short while. The client uses one of the CloverETL server HTTP APIs to access its functionality remotely. The client is connected to an HTTP load balancer which hides the details of the cluster from him. The HTTP load balancer forwards the client's requests to one of the live cluster nodes. The cluster node that receives the request can decide to forward it to some other node based on a load balancing algorithm. All of the nodes shared the same configuration database and transformations and data stored on shared file system. Now I'll begin with a live demo of the CloverETL cluster. Here you can see the web interface of the CloverETL server. My browser is also connected to the HTTP load balancer, so it's not connected to a specific cluster node. This is a view of the server projects, or sandboxes as we call them. They contain all the transformations, their data, metadata, and so on. All of the cluster nodes access the same sandboxes via a shared file system. As I've already mentioned, the cluster nodes share the same configuration. An example of this would be user management, or scheduling. This cluster consists of 3 nodes. All of them are running on different physical machines and are available via their specific HTTP URLs. The nodes have different hardware configurations. Currently, no transformations are running in the cluster, which you can also see in the main monitoring view. What I'll do now is use a shell script to run a large number of short transformations on the cluster. The transformations executions will be spread between the cluster nodes by an automatic load balancing algorithm. The shell script uses the server simple HTTP API, which is designed for use in scripting, and in this case we use the wget tool to send HTTP requests. The shell script also connects the HTTP load balancer, which forwards its requests to live cluster nodes. The result of each request will be the ID of a running graph. I'll start now. We can see the HTTP request being sent and the returned IDs of the running graphs. In the cluster monitoring view, we can see the transformations are being executed on all of the cluster nodes. You can notice that the executions are not spread evenly onto the cluster nodes. The load balancing algorithm takes multiple information into account. In this case, the number of CPUs is quite significant. The algorithm can be configured so you can fine-tune it for your specific needs. What I'll do now is shut down one of the cluster nodes. You can see that one of the cluster nodes has disappeared, but transformations continue to run. The HTTP requests are still being sent and executed normally. The HTTP load balancer forwards them to one of the live nodes, which then perform load balancing. This is all for the basic demo of CloverETL server clustering. I've shown you the scalability of the cluster by running a large number of transformations which were distributed among the cluster nodes. I've also demonstrated failover, in which case the HTTP load balancer and surviving nodes transparently continue to serve the client's requests. Thank you for watching.